Hi, hello guys, welcome to the video. Here in this video, we are going to learn how to draw free body diagrams. And let us first understand what is a free body diagram. In engineering mechanics, we mostly deal with the bodies on which so many forces are acting, especially in statics. So we need to have a clear focus on the forces on the body. For example, focus on a body on which so many forces are being acted. We have to focus on all the forces which are being acted on the body, right? So, in order to visualize all the forces without any confusion, there might be so many forces acted on the body with different applications of forces, with different sources. But what happens is there must be no confusion. We must avoid the confusion. So to avoid confusion and to visualize the forces very clearly, free body diagrams were introduced. In order to understand what I have said, let us go with some examples. You will understand it in a more clear way. On the screen to the left, you can see one image on which you can see one red ball which is being hanged and hinged to a vertical surface. This is the vertical surface. This is the vertical surface to which a hanger is fixed, and with the help of a string the ball is being hanged, right? And the ball will have some weight which always acts vertically downward direction, right? And you can see there is a contact between the vertical wall and the ball here. Here what is happening is the ball is being pressed against the wall. The ball is being pressed against the wall in this direction. And what is that wall doing? And that wall is also offering an opposite force to the ball. And that is the reason the ball is not going beyond the wall. If the wall does not offer any force onto the ball must hang like this. But there is the wall which is an obstacle for the ball to move. That is the reason the ball is hanging like this. Clear? So here we can clearly say that on the ball, the vertical wall is also exerting some force, and that force is directly equals to the force which is being applied on the wall by the ball. For suppose, let us say this ball is exerting a force of Fb, and this Fb is equals to the force which is being applied by the wall on the ball. That can be Fw. Why? Because these both must be equal in order to attain the equilibrium, right? In order to attain the equilibrium. Here let us try to draw the free body diagram for this particular figure. Free body diagram. So we have to analyze what are the forces being acted. So let us remove all the supports. First step we have to do is we have to remove all the supports. Let us draw this ball as usual. On the ball, what are the forces being acted? One force is being acted vertically downwards, that is always the weight. And another force which is pulling the ball in the upward direction, which is an inclined force in this direction. String. See here you can see the string. The string tries to pull the ball in the upward direction because the weight always acts in the downward direction. In order to keep the ball at the same position without coming down, the string has to pull the ball in the upward direction, right? So in this direction, let us change the colors. This is the weight, and this is the force by the string on the ball, right? What we are doing here is we are focusing on the forces which are acting on the ball itself, right? See here one force, that is the force offered by the string, that is indicated with the red color, that is pulling the ball in the upward direction. So the force is applied on the ball itself. So that is why I have mentioned this force in this direction. And the weight of the ball is always acts in the downward direction. And weight is also one of the force which is acting on the ball, right? And there is one more force we can see. And this is the force, see on the figure, This is the force which is offered by the ball to the wall. But what we are focusing on? We are focusing on the forces that are applied on the ball. We are not focusing on the forces that are applied by the ball, but we are focusing on the forces which are applied on the ball, right? So on the ball, another force is being applied. That is the force which is applied by the wall. So in this direction, the force is applied by the wall. And whatever force that acts on this body, that force must pass through the geometric center of that particular body. So here the geometric center, let us have a deep look into this body. So here you can see the geometric center will lie at here, somewhere here, right? This might be the center, maybe. This is the center. And whatever force that acts on the ball must pass through the center of the body. And here there is a contact, you can see. And through that contact, a force from the wall is being acted on the ball. So let us join this contact with the center. So I have joined both of them. So this is the line of action of force. Line of action of force. Which force? The force applied on the ball by the wall. So this is the force which is perpendicular to the wall. Perpendicular to the wall. Right? Perpendicular to the wall. So here we can directly mention this force. This can also be called as force, also called as a reaction applied by the wall on the ball, right? This is how we have to draw the free body diagram. So this is the final free body diagram for this force. Let us go with some more example. For example, a tub is there in which two balls were placed like this. Two balls were placed like this. Assume that both of them were in circular shape. So like this, two balls were there. Here, let us consider the first ball's name is A, second ball's name is B. And let us write them somewhere. A and this is B. Let us also indicate the geometric centers. So this is the center, this is the center. So each ball will have some radius, of course. And let us try to draw the free body diagram for ball A first of all, and also later for ball B. FBD for ball B, FBD for ball A. Right. Here, let us take the first ball. The first ball will have vertically downward directed force, that is weight. So let us draw the ball here. Let us change some colors. Okay, fine. So weight is the one of the force which always acts in the downward direction. I have shown one of the force that is acting on the body, and another force is being acted right here at this point. I made a mistake. Wait a second. I will erase this thing. Oh, right. This is how the contact between the ball and the container will be. So on the figure, from the figure you can clearly see one thing. So here there is a contact being maintained by the container surface and the ball. So there, at this point, a force is being applied on the ball, and that force must pass through the center of the ball, right? This is the center of the ball, and this is where the force applied. So let us try to pass the force. This is how the force is applied, and that force is perpendicular to the surface, right? Perpendicular to the surface. So let us write that force. So this is the force which is being applied. This is how a force from the container surface is applied on the surface of the ball. This is second reaction, and we have another one. So here at this point you can see there is a contact maintained between ball to ball. Here this contact, from this contact force is being applied on the ball. See, this ball while coming down will apply the force on the lower ball. But what happens is, this ball is also applying the same force which is being exerted on it by this big ball. Clear? See, let us understand it in a more clear way. See, this ball is coming down. So it exerts a pressure on this, it exerts a force on this body. But this is the force which is this ball is applying on this ball. And what this ball has to do? This ball has to apply a reverse force which is equal to this force. So you can say this force and this force both are equal. So in order to maintain the equilibrium, right? In order to maintain the equilibrium, right? Let us erase this all. Equilibrium. So here the force is exerted on this ball. So how is the force exerted? Wherever the force exerts on the body, that must pass through the center of the particle. This is where the point of contact. This is the center of the body. Let us join both of the points. So slowly and gradually try to join the force. So this is how the force is acted. So also draw this force. How is this force acting on the body? This is how the force is acted on the body in this direction. So in the question, he will give all the angles and all the distances, all the lengths. So he will perfectly measure the distances through the angles. With the help of those angles, you can place this force accurately with its accurate angle. So let us go for the second body, free body diagram for B. So here, this ball is having total 3 contacts, right? So for all the 3 contacts, you have to place the forces. So from the bottom, you can see there is a contact maintained here, and the weight is always acted in the downward direction, and the bottom of the container will also exert some force towards in the upward direction, right? And that force is like this. That is known as reaction. And here at this contact, right? Here at this particular point, there is a contact being maintained by the body, ball B. So that force will act on the body like this. And there is another force being acted on the body, that force offered by ball A. So in this direction in the sense, this same force in the same angle that can be placed here, right? So here we can imagine ball A. So here contact is maintained and that pass through this in this direction. And this is the free body diagram for ball B, and this is the free body diagram for ball A. I hope you have understood. And we have to understand one thing. On writing, while drawing free body diagram, we are focusing on the forces that are acting on that particular body. If you take one ball, if n number of forces are acting on the body, we have to take only the forces that are acting on the body. There might be forces that ball is exerting on so many, but we have to focus on the ball and how many forces are acting on the body, right? This is how we have to draw free body diagrams. If you have any doubts, post it in the comment box. I will try to explain in a more better way. Thank you so much.